Alright, we're going to try this one more time. I've got two videos so far up here. If you watch them all the way through to the ends are really terrible. I don't know what happened with the last one. I hit the record button to stop recording, and I guess it just kept going. So there's one other type of problem in here that is kind of tricky. It's got everything's in terms of y's. Now you've got two options. Option number one is just deal with the problem the way it is, which can be a little bit difficult. You got to think sideways. So in this particular problem, we've got a parabola, but it's not opening up or down, it's opening left or right. So it's a positive 3, which is going to move us up 3 on the y-axis. And it's a negative, so it'd normally be opening down, but we have to actually make it open left instead of opening right. So it's going to look more along the lines of this as we go along. And if you're wondering how I'm getting these points, parabolas go by squares. So as I went down one, as I went over one, I went down 1. So I went 2, I go down 4. If I go over 3, I got to go down 9. So this 3 up, 6 down. That's how you can get a really precise parabola without that much work. They're harder to draw sideways in general, especially on one of these machines. Now drawing lines, it might even be easier to just rewrite it in terms of x. So x equals y plus 1, and then so your y equals x minus 1. And then just use your normal y equals x, mx plus b. In other words, you're going to have to realize that you have an x-intercept and all that fun stuff. Alright, this one's very similar to one of the problems we did earlier, but we're really looking for this area right here. The area that's between these two bottom regions. So we got to figure top minus bottom, but when you're going sideways, you got to think right minus left, or just turn your whole page sideways and go, okay, which one's on top? This one's on top, this one's on bottom. And this is on top and this is on bottom. 10 here would be the top of the page, not the bottom of the page. So if you're going to turn it, you got to make sure that you make this be the top. However, we still got to find our intersection points. We got to find places where each of these intersect. So set them equal to each other. 3 minus y squared equals y plus 1. Get everything in the right. 0 equals y squared plus y minus 2. So y, like I said, y and y, 2 and 1, plus 2 minus 1. So y equals 1 and negative 2. Now, one doesn't kind of jump above the other, so all we're going to do is our bottom, which is our line in this case, y plus 1 minus our top, which is, oh, bottom minus top. What in the world am I talking about? It's always top minus bottom. Bottom minus top doesn't even make any sense whatsoever. So top 3 minus y squared minus the bottom, which is our line, y minus plus 1, dy in this case, because everything's in terms of y. Now if we do the bounds in some other variable other than x, we just got to make sure they're in whatever variable it is. This is not really left to right now, it's bottom to top. So it's negative 2 to 1. After that, distribute, and you solve. So that's pretty good. Let me show you the other way of doing this. So go down to number 8. The easiest way of doing one of these problems, by far the easiest way, is x and y are arbitrary. Unless x means something and y means something, who says it's the x-axis and this is the y-axis? Let's just say x equals y. I'm going to still get the same area between the curves. And if nobody cares what my work looks like, if it's a multiple choice question and such, you just really want to write this as f of x equals x times 2 minus x, and then g of x equals negative x. Oh. And then all I've got to do is graph them now, and everything's in terms of x. Now, even easier than distributing this and trying to figure out what this is going to look like, I can find the zeros of this really easy. If I plug in 0 here, I have a 0 at 0. If I plug in 2, I'm going to have a 0 at 2 here. So I've got a 0 here, a 0 here. The only question is this opening upwards? Is it opening downwards? So if I was to distribute, I get 2x minus x squared. It's a negative parabola opening down. So this looks something like that. And negative x. Oh, I see one of my intersection points. Nope, gotta go the other way. Down 1 over 1. So now I want to find my area between the two curves, top minus bottom. And just like all the other problems, I just have to figure out what the top equation is minus the bottom equation. So our top is x times 2 minus x, or the other version, minus our bottom, minus a negative x, or plus x dx. And then all they have left to do is find your bounds. And you find your bounds by setting the two equal to each other. All right, let you finish that on your own.